We come again, ladies and gentlemen, to another adventure with electrostatics, and this time an experiment which has what one would call some practical, some technological usefulness. Now, what are we going to do? I point out that we have a glass cylinder with a cork stopper below and a cork stopper above, and through each cork stopper is a metal rod that is pointed. Do you see that in there, Andrew? Yeah. Andrew? Right. And this rod here is also pointed, and they have some separation. In addition, there is a glass tube entering the lower stopper. You see that?
Yes.
And I am going to blow some smoke in there from a cigarette so that the chamber gets filled with smoke. Now, smoke contains many particles, some charged and some uncharged. Those that are charged will certainly take some direction to positive or negative, right? Depending upon the charge they carry. And those that are not charged may be charged because of the nearness to the electric field at the end of each rod. So let me now light a cigarette, a matter which does not appeal to me very much because cigarette smoking, are we not agreed that it has no good effects on humankind, right? Cigarette smoking, but notice how difficult it is for me to do this. Incidentally, why do I take off the upper stopper? Why do you think?
To let air in.
No.
To put the smoke
in. No, I'm going to put the smoke in down here.
So it'll stay.
Well, not quite. Now watch it and think about it. Thank you, Mr. Anderson. Mr. Anderson is closing the upper. Do you see that if the upper stopper were in, would it not be more difficult for me to drive air in? Now I'm going to turn on the electrostatic generator, the Van de Graaff generator, and we have one connection to the upper terminal, and the lower one is grounded, so that there will arise a great difference of potential, several thousand volts, maybe 100,000 volts between those 2 points. And we want to see what happens. Watch it now. Watch. Watch. Do you see? Do you see? Did something happen?
Yes.
Did you not see great turbulence arise? And notice, is not the smoke all gone?
Yes.
That's fantastic. The smoke is gone. I'm going to do that again. Why? Because it is useful for us to see. And are you not agreed? This could be used in great factories where smoke belches out of their smokestacks and thus save the people from being flooded and buried and smothered in the gases from the chimneys, right?
Yes.
Do you see the usefulness of this? Wait, Mr. Anderson. Thank you. Notice how dense the smoke. Thick, murky-like. Indeed, my own city of Los Angeles is suffering very much. And it's likely that all the cities of the world will suffer in the same way if some effort is not made to abate this nuisance. So now let me, I can't see it, Anderson. You're hiding it from me.
Can you play the monitor there?
Yeah, oh, yes. Notice that. Notice. Isn't it wonderful how that cleared up?
Very good.
I say that's very dramatic. And so we have some usefulness arising from these experiments which one would say have little usefulness and little purpose. Isn't this a remarkable thing to see?
Yes, yes.
Now remember, I have not answered all the questions that would arise if we were to explore this subject more deeply, but are you not agreed you can do this with your classmates and with your teacher?
Yes.
See, why did these things happen? You must look into it very circumspectly.
Where did this smoke go, Professor?
Where? That's the best question yet. Where did the smoke go? I have the choice of answering it or not answering it.
Did it just disintegrate?
No. I don't like that disintegrate. But you know my philosophy from having seen me on other programs. What do I do mostly with questions that are asked of me?
I haven't seen you before.
Oh, you have? Say, young man, this is absolute treason. Have you seen me, Andrew?
Yes.
Thank you very much.
We haven't got
Notice this
TV.
man nearly gave me another heart attack. But anyway, let me talk to you. I'm not going to talk to him anymore.
We haven't got TV, Professor.
Oh, you haven't got TV? Oh, well, I understand that then. I'll forgive you this time, right? So, when the question arises, should I answer the question or should I not? What is my philosophy?
You usually leave it to think about.
Thank you, sir. You are of my mind and heart, and I wish you great success. So you better take this up with your teacher, because if I answered the question, then you won't think about it anymore. And what is my ambition? That you think about it. Right, very good. We have returned to show further demonstrations in electrostatics, and again we come to that great and wonderful invention of the last century, the Wimshurst machine, where charges are separated and stored in Leyden jars, and I shall speak soon about Leyden jars, so that we have a great energy available between the two electrodes. A great energy. Whoa, that's enough to knock a horse down. Now, although I showed this in one of the recent programs, there is another feature which I wish to point out, and it is this, that when a heavy spark occurs in the air, as during lightning, a strange and wonderful phenomenon arises, the production of something in the air, which is wonderful to detect. Now, regarding detection, is it not true, Michael, that we get some ideas of the world around us through our sight, right?
Yes.
Through our sight. So you see, sight is a very wonderful thing, and you should think about it. Aren't you heading for medicine?
Yes.
See, maybe you will have adventures with the human eye. That would be a wonderful thing, wouldn't it?
Yes.
So, we see things, we hear things, but there is another sense which we don't too often use adequately, and that is smell. So I'm going to run this machine, and I want you to tell me if there is anything strange to detect. First, get your noses in here. Do you smell anything?
Yes.
Do you smell anything? Not much. Now watch. Watch. Let us run the machine. Notice the great energy which is doing something to the oxygen in the atmosphere. Now, get in. Do you smell anything? No, you told me you had a cold, and therefore your olfactory sense is impaired. How's that for a sentence? Do you know what your olfactory sense is?
No.
Yeah? Well, it's connected with your nose, and you look that up when you get home, okay? How about this, John? Do you smell anything? Do you smell anything?
A burnt spark.
Yeah, that's it. There is the production of ozone, a very remarkable event in the behavior of nature. So think about that next time we have a lightning storm, a rainstorm. And what else is beautiful to look for in the heavens after, during a rain? What's an important thing to see?
Rainbow.
Rainbow, exactly. And when you see a rainbow, can you tell me, where do you see it? Where is the sun and where are you when you look at a rainbow?
The sun is just about directly behind it.
Very good. That's excellent. And tell me, do you always see, is it only one rainbow or how many rainbows do you see?
It's around about 6 or 5.
Whoa, I have never seen 6, I've never seen 5, but there are always 2. The primary, the brighter, and the secondary, less bright, and the others, if there are any, less bright still, so it's very difficult to see them. Now, do you know the order of the colors, say, on the primary bow? Think about that. Let's go to some more experiments. Here's one that enchants me. It has to do with electrostatics, and I call this my dancing devils. You remember the slab of stuff I had before was lucite? I think you people here call it perspex. Well, here is a little thin lucite box with a cardboard bottom, and do you see I have here some little pieces of paper? See it? Now I call this my dancing devils, and watch what's going to happen. Watch. Look at that. Do you see why I call them dancing devils? Isn't that amazing? Yeah? Isn't that terrific?
Could you have wood under there instead of cardboard?
Wood is all right. And could you not make one? Or could you not go to some shop where they sell goods which come in such boxes and ask for one and have a lot of fun? Now the question is, why do these do what they do? Watch. Yeah. A little difficult sometimes to make things work. Look at that. He's crazy. Watch. What? Well, did you see? That's what I wanted you to see. I discharged the upper, and there do you see what's happening? He goes from here to there and from there to here. And I want to know, you know it's my practice to raise some questions and leave them unanswered. Have you not discovered that, in the earlier programs? So I want you to discuss with your master why it is that when I put my finger there, well, that one's not working. Why it is, watch, well, oh, I'm having more fun than a barrel of monkeys. Look, did you see it? Did you see it?
Yes.
Why does it leave one place and jump to another? And then make, oh, do you see? Why does it do this? And if you understand these things, you will understand a great deal about these electrostatic forces.
But it has something to do with when you rub plastic hard, it picks up paper.
Indeed, indeed. And if you see the first program or two that I did, you will discover that we made some adventures in this subject. What is your ambition in life, John?
Architecture.
Architecture. Oh, that's a wonderful ambition. So you need to know lots about the strengths of materials
Yes.
and bending moments of beams. And I hope you get a chance to go around the world and see what other great architects of history have made. So now, I wish to dispose of a letter from a little boy about your age. You'll forgive me for calling you a little boy, all right? Here is a young man who writes me from Queensland with this question. Dear Professor Miller, please forward the solution to the unified field theory by return mail. Now, isn't that something? Please forward the solution to the unified field theory. Now, I am delighted to have this letter from this young man in Queensland. It shows his interest in modern physics, but I would remind him and you that it took Einstein 30 years or more to labor on the theory, and this young fellow wants me to give him an answer by return mail. Isn't that terrific? But now, another more reasonable question. Would you please give me a simple definition of physics? Yes, I'm prepared to do that. Here in these programs, John and Michael, here in these programs, we are exploring this question. How does nature behave? And that's what physics is. How does nature behave? So if you study some physics, remember this is the question you must ask. Why does nature behave in this way? Or as Kepler said, why are things as they are and not otherwise? We have come again, ladies and gentlemen, with further experiments in electrostatics, and this one perhaps the most profound of them all, because I'm going to talk about a wonderful instrument called a Leyden Jar, L-E-Y-D-E-N or L-E-I-D-E-N, from the town in Holland by the same name. But before we go to that, let's introduce our two new visitors from St. Aloysius. Your name?
Daniel Madigan.
Daniel Madigan. My pleasure, Daniel.
Peter Flower.
Peter Flower. Peter Flower. Uh-huh. Daniel in the lion's den, right?
Yes.
All right. So we're going to talk about a Leyden jar. And notice, men, what it consists of. A metal can, a cup, a glass vessel, and another metal cup that has a pointer on it with a knob. This is called a capacitor. Indeed, any two metal plates separated by some distance with stuff between or not could be called a condenser or a capacitor. Now this one, you see, can be taken apart. This goes inside and this goes outside, and I'm going to do some remarkable experiments. Now you watch what happens. Here is a Van de Graaff generator. The spelling, incidentally, V-A-N-D-E, capital G-R-A-A-F-F, Van de Graaff. Indeed, when I was a boy about your age, he invented these at MIT in Massachusetts, and I saw the original ones, nearly as big as this studio. Imagine it, huge spheres standing on huge insulating columns with which the men explored high voltage discharge. Now, we are going to make contact of this inner knob with that machine there, and thus store some energy in this vessel. That's why it's called a capacitor. You see, it has some capacity, in the sense pretty nearly of a vessel being able to hold so much water. But you must be careful of this hydrostatic analogy. So, Mr. Anderson, will you give us the machine? Oh, that's enough. That's enough. That's enough. Watch now. Yes, do you see the energy in there? And incidentally, I was getting a discharge from somewhere, Do you see? These things are risky, and you may indeed be in the lion's den. Does your mother know you're here? Yes, I'm glad of that. Notice, I'm going to discharge this. Oh, yes. Now, watch. I'm going to charge it again. Mr. Anderson?
When you're ready.
Ready. Let's have it some more. Some more. Good. I want to show that there's energy there, so I connect the outer and the inner. Watch it now. Watch. Watch, boys. Do you see? An enormous measure of energy there. And incidentally, there is some forevermore, but more and more feeble as time goes. Get in here close. Watch there. Watch. Did you see a little? Yes. Now I'm going to do the remarkable thing that I want to do. Watch me. Wait, Mr. Anderson. Wait. Please. A little more. A little more. That's enough. Thank you. Now I am going to disassemble that. I'm going to take it apart. Watch how I do it. I have taken the innermost out, and I have taken the middle one out, and am I not connecting them all with abandon, right? Would you not think that if I ground this to this and this to this, that all the energy would be lost? Would you not think so? Yes, beginners think this. But watch now what happens. I'm going to assemble it. Watch. Get in close. Watch. Watch. Do you see? The energy is still there. How do you like that, Father? Isn't that amazing? Yes, and there are some more there. Yes. Yes. And watch. Get in close. Get in close. Did you see it? A little spark. So the question arises, how is it that I can charge this Leyden jar, disassemble its parts, reassemble it, and still have the energy there? And I think on the next program I will take time out to explain this, since it is pretty tricky. But I should say some more about these Leyden jars, Peter and Daniel. When, in Holland, Peter von Muschenbroek, a Dutchman, discovered how to make these, he made an enormous one, and even though he wasn't equipped with machines such as we have for producing charge or separating charge, he did succeed in charging a Leyden jar and accidentally got shocked. He was nearly killed. He had pains in his chest and in his arms and in his head. And what was his phrase after? I would not take another such shock for the kingdom of France. Imagine that. Now, more historical. The story of this Leyden jar business reached Ben Franklin. You know Ben Franklin, don't you, men? Ben Franklin in America. And Ben Franklin was enchanted by these electrostatic experiments. Do you know a classical one that he did? What did Ben Franklin do, classical? The kite, the kite, right, and the key and the string, right. So, Ben Franklin did some experiments with Leyden jars, and he was nearly killed. And he wrote to a friend and said, do not make this more public, P-U-B-L-I-C-K. I just love that spelling. Do not make this more public, for I am ashamed of my folly. Ben Franklin. Isn't that wonderful to know about? How's our time, Mr. Ambassador? 7 minutes gone. Let us return to our table here and raise a question or two about some interesting things. In an earlier program, ladies and gentlemen, indeed in the first one, I said that I would not necessarily confine myself to physics because there is all the world to think about. And here is something that I have brought from America because of its beauty. Do you see this wonderful thing, men? Notice, it is sand, which is gathered together, and it's hollow inside. And do you see it has a beautiful pentamerous figure on the outside? Look at that. This is called a sand dollar. Do you see it looks like a silver dollar, I suppose? Notice the beauty of this. Can we get tight on it so that we can see? That's wonderful. Look at that. Always five, what shall we call these? Leaves. Here is another one. And imagine, this was a creature that lives in the flats in the not-too-deep sea. And I say that is wonderful to think about. So, one more little exercise to show you how great a role imagination can play in your lives. Here is an animal. Do you see that creature? Have you ever seen anything like it? Can we get a tight shot of that, if you will, please, Mr. Cameraman? Isn't that an uncommon creature? Have you ever seen anything like it? No. Never. No. Well, no, neither has anybody of the human race. Why? Because when I am working at home and need it quiet, my wife engages in some imaginative adventures, and she put that together from turkey bones. Isn't that fantastic? Look at that. Can we get another view of it? From turkey, let's get a full look at that. Look at that creature, born out of her mind. So, what I want to do is leave for the young people of Australia who will see this program the following exercise. Find an appropriate name for this Cantabulus horribilis terribilis or something. Find a good name for it, and I will discover some proper reward for the best name that is sent to me, and you may write me to America. Isn't that a good exercise? To think up a name. Thank you very much for being on the program. Thank you. And we shall return another day with some more of the strange and wonderful things in nature.